Hi everyone, today we're going to be taking the 2.2 notes called the limit of a function. So let me start with what is a limit? That's the question of the day. So a limit is basically a y value that a function approaches from both sides of a certain x value. I'm going to explain what that means, okay? But a limit is a y value. So anytime I ask you, what's the limit of this function? Please make sure that your answer is a y value on that graph. So I'm actually going to start with an example. And I want us to take just this random graph. Let's see. Oh, I don't know. Whatever. We're going to call this graph f of x. And I'm going to randomly pick a value of x. Let's just call it 2. Whatever. Let's say this is 3. Obviously, I'm just making stuff up. So clearly there's a point on this graph, 2, 3. So what I'm going to ask you is this. I'm going to ask, LIM is short for limit. There's going to be a little tiny thing down here. This means x approaches 2. This little plus sign is going to mean from the right of f of x. So the way you read this is the limit as x approaches 2, the little plus sign means from the right, of this function f of x. So what I'm going to do is I'm going to look at the function. I'm going to find x equals 2. I'm going to go to the function, and I'm going to approach this dot from the right, incoming from the right. And I'm going to stop there when I get to x equals 2. And I'm going to ask myself, what's the y value there? Well, it's 3. Then I'm going to ask you, what's the limit as x approaches 2 with a little minus sign? That means incoming from the left of the same function. So I'm going to go to the graph. Here's 2. I'm going to approach this dot from the left on the curve. Incoming from the left, like so. And when I get there, I'm going to ask myself, what's the y value there? 3. Okay, so we call this one the right-sided limit. That means we were approaching the number 2 incoming from the right. This one we call the left-sided limit. So these are the two one-sided limits, okay? These are called one-sided limits because we're looking at approaching 2 from either the right side or the left side. And then we have the limit, not one-sided, but just at the 2. So we say, what's the limit as x approaches 2 of that same function? Well, basically, when there's no plus or minus, it just means at the 2. And what you do is, if you haven't done your one-sided limits, is you're going to have to do them. You look at the graph and you approach 2 from the left and the right. And if they meet up at the same y value, then this limit is that y value. It exists. So basically, moral of the story, in order for a limit at that x value exists, then your right-sided and your left-sided limit have to be equal. Okay, let's do another one. What about same graph? Let's do the same graph. Okay, call it f of x. Make this a 2. Oops, I meant to put a hole here. So there's a hole, let's say. Okay, so, oh, by the way, I'm sorry, let's go back to 1. I was going to ask you, what is f of 2? The function value at 2. It is 3. Okay, just note. Here, I'm going to ask you the same question. F of 2 equals, what is the function value at 2? Well, the hole means there isn't a point there, so guess what? does not exist. There is no function value. Okay, now that's just a side note, and I'll tell you why I'm telling you that later. Let's do our two one-sided limits. The limit as x approaches 2 from the right of f of x. The limit as x approaches 2 from the left of f of x. And then the limit as x approaches 2, so at 2. Remember, in order to answer this, you have to first analyze the right and the left. So, incoming from the right, looks like there is no y value there. But remember, a limit is a y value that we're approaching. That means getting closer and closer to. I mean, if I'm at 2.00, right this point, 2.000000001, comma, you can bet your bottom dollar that I'm going to be super close to 3. So the limit is 3. Look, that point doesn't have to actually exist for the limit to exist. You can have a limit without a function value because we're just approaching that number. We're getting close to 3. The limit from the left is going to be the same. So guess what? The limit as x approaches 2 from both sides is also 3. Okay, let me move on. Let's do another one. Same graph. Okay, it's the same graph with the open circle. Okay, we'll call it f of x again. Oh gosh, I forgot my open circle again. Sorry, my bad. And then let's put a dot here. Okay, so this is still 2. Let's call this -1. Let's call this 3. Okay, I'm going to ask you a series of questions. 1. What is f of 2? So this function is this whole graph. It's the squiggly line and the dot. This whole thing is f of x. So maybe I should just put f of x here so you know. This whole graph is f of x. What's the function value? It is -1. So this function value exists. The function f of x has a point at x equals 2. It is -1. It jumped, but that's fine. So now I'm going to ask you the limit questions. What's the limit as x approaches 2 from the right? What's the limit as x approaches 2 from the left? And what's the limit at 2? Okay, well, I think we know in order to answer this last one, these two have to match up. So let's see. If I'm approaching 2 from the right, then I go onto the curve. It looks like my y value, still that I'm approaching, is 3. Then I go to the left side of 2, and I approach on the curve 3 also. You might be wondering, well, yeah, but at the 2, the function value is -1. Yes, but all of these other points, what y value do they have? Nothing near -1. They're all approaching this y value, and this y value, and this y value, and this y value. This y value, this y value, this y value, this one, and this one. They're all approaching +3. So guess what the limit is? It's 3. What if I ask you to say, how come you know it's 3 for this one? What if I say justify? Justify why the limit as x approaches 2 of f of x is equal to 3. Well, you would say because the limit as x approaches 2 from the right is equal to the limit as x approaches 2 from the left. That is your reasoning. This I will ask you for sure. Okay, let's do a few more. Let's see. Okay, so different graph. Let's do a different graph. Let's go like that. Let's put a dot here. This is definitely a piecewise function, so let's call it f of x again. So I want us to do limit as x approaches, let's call this a 1 here. 1, okay. Let's make this a 1, let's make this a 2, let's make this a -1/2. Okay, The limit as x approaches 1 from the right. The limit as x approaches 1 from the left. And then the limit as x approaches just 1. All right, so here we go. How about the limit as, here's 1, x equals 1. Plus means from the right, so I go to the curve. It has to be this one. There's nothing else on the right side. And I'm incoming to x equals 1 from the right. What's the y value there? Even though the y value doesn't actually exist, all these y values are approaching positive 2. How about from the left? Here's 1, approaching 1 from the left. Incoming from the left, it looks like the y value there is negative 1/2. So what's the limit at 1? Well, guess what? If the right-sided limit and the left-sided limit are not equal, the limit does not exist. What's your because? Your because looks like this, except they're not equal. So you say because the limit as x approaches 1 from the right of f of x does not equal the limit as x approaches 1 from the left of f of x. Okay, let me move on. Oh, you know what I was going to ask you? What's f of 1? What's f of 1? Here's 1. The answer is 1. Okay, let me move on. Oh, I know. Here's a good one. What number am I on? 5. So let's do that. And this time I want a graph with an asymptote, a vertical asymptote. Your favorite, you guys. Okay. And I want the graph to look like this. I'm going to ask you a whole bunch of questions about this. Okay. So first of all, what's f of 2? What is the function value at 2? Is there, when x is 2, a y value? Well, no, there's a vertical asymptote. That's domain restriction, so doesn't exist. Okay. B, what's the limit as x approaches 2 from the right of f of x? Well, here's 2. So incoming from the right would be like this. This is what your eyes are doing. Remember, a limit is a y value that we're approaching. Well, it looks like this graph is going up forever. And so what we say for a limit is that this limit, if these y's are getting bigger and bigger and bigger and bigger, then the limit is positive infinity. It's not DNE. It doesn't mean it doesn't exist. It just means those y values are getting higher and higher and higher, infinity. How about the limit as x approaches 2 from the left? Well, let's see. So here's what my eyes are doing. Right, this way, incoming from the left, approaching 2, it looks like they're also going to infinity. So you know what question I'm going to ask you next. I'm going to say, what's the limit at 2? Well, remember, if the right-sided limit and the left-sided limit are equal, then the actual limit is that number. So basically, if I hadn't asked you these two and I just asked you this, my eyes would have to do the left and the right at the same time. And if both behaviors are the same, and by behavior I mean the y values are both approaching infinity, the answer is infinity. Okay. What was I going to ask you? By the way, do you know what graph this is? It's the parent. Remember this graph? Remember this one? It looks like this. It's got an asymptote here, like so. So what does this one have to be if it's been shifted 2 to the right? If the asymptote's gone 2 to the right, it's going to be x minus 2 squared. Hence the domain restriction of 2, right? Okay, let's do another one. Oh, I know. How about y equals 1 over x? Who remembers what that graph looks like? We're going to have to know all of these graphs. We call this the reciprocal function. It's got an asymptote at x equals 0. It also has an asymptote at y equals 0. By the way, this one also had an asymptote. It's asymptotic. Okay. And the reciprocal function looks like this. Okay? So let me ask you a series of questions. 1, what's the limit as x approaches 0 from the right of f of x? Well, I'm calling it y. Why don't I call it f of x? So to be consistent. So this is the f of x graph. Okay, here's 0. Approaching 0 from the right would be like this. What are those y values doing? They're going up to infinity. B, what's the limit as x approaches 0 from the left? Well, here's 0, x equals 0. From the left is this. So guess what? Those y values are getting smaller and smaller forever. So that's negative infinity. And I think by now you know that the limit at 0, since the right and the left limits aren't the same, is going to be does not exist. I'm going to ask you a few other questions. What about if I say the limit as x approaches positive infinity? Remember, note there's no plus or minus sign from the left, from the right, because it doesn't make sense to say from approaching infinity from the right side or approaching infinity from the left side. It doesn't make sense because infinity is just arbitrarily large. So you can have a limit as x goes off to infinity, and you can have a limit as x goes off to negative infinity. So what does that mean? What do your eyes do when they look at the graph? Well, as x approaches infinity means look at all the x values that are getting larger and larger and larger forever. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right forever. So I'm asking you in this problem to look at the graph as it goes to the right forever. Okay, so remember, a limit is a y value. So what y value are these points, do these points have as x gets larger and larger? They're getting closer and closer to the x-axis, which means y is approaching 0. How about as the graph goes, this means to the left forever, goes to negative infinity forever and ever, this way. Remember, this graph just skims the bottom of that x-axis to the left forever. What y value is it approaching? I know the y values are all negative, but they're getting closer and closer and closer to the x-axis, which means they're getting closer to 0. Now, I cannot ask you for a third limit involving infinity. These are the only, they're not called one-sided limits. This is, the limits to infinity are different than limits approaching a certain numerical value of x. Okay, let's see. Oh, now let's start. Almost done here. Hang in there. What if I have the following piecewise function? F of x is equal to x squared if x is less than or equal to 0, and negative x plus 2 if x is greater than 0. Well, you had better be able to graph this because we want to see the graph in order to answer the question. So one piece of this function is x squared. That's just a regular old parabola, but only to the left side of 0. So it looks like this, and it looks like we are also including this dot. It's not going to be an open circle. Then the other half is to the right of 0, so on this side, and it's a line with -1 slope and up 2. But I'm going to put a open circle at 0, comma 2, and then -1 slope. Okay. So here are my questions. What's the limit as x approaches 0 from the right? What's the limit as x approaches 0 from the left? And what's the limit as x approaches 0? Okay, so approaching, here's 0, x equals 0. So approaching it from the right means I'm looking at the graph like this, incoming from the right. It looks like the answer is 2. How about x approaches 0 from the left? So my eyes are going like this, incoming from the left. Looks like the y value I approach is 0. So guess what? What's the limit at 0? It's dne because, doesn't exist, because the limit as x approaches 0 from the right of f of x does not equal the limit as x approaches 0 from the left of f of x. Okay, let's do another one. How about if f of x is equal to tangent x? Oh, one of our favorites, I know. So what does the tangent graph look like? Remember, it's got an asymptote at negative pi over 2, another asymptote at positive pi over 2, and then it does a little squiggly like so. Let's do one more period of this thing, like that. Okay, and here's my question. What's the limit as x approaches pi over 2 from the right? What's the limit as x approaches pi over 2 from the left? So here's pi over 2. From the right, incoming from the right means you're actually looking at this branch and your eyes are going like this. It looks like that limit, that graph goes down forever, is going to be negative infinity. And then approaching pi over 2 from the left, here's pi over 2. So from the left means this part. So my eyes are going like this, and I'm asking myself, what are those y values doing? They're going up to positive infinity. So what's the limit at pi over 2? If my right and my left limits were not the same, it does not exist. Okay, I've got 2 more examples. All right, number 9. How about the limit as x approaches 2 from the left of x over x minus 2? Well, you know what? In order to answer this question, see, this is f of x, you're going to have to be able to visualize this graph. So we know this has a domain restriction at 2. Domain restrictions are either holes or they are vertical asymptotes. How do you know? Well, if you can't cross out x minus 2, if you can't reduce x minus 2, it's a vertical asymptote. If there was another x minus 2 up here and I was able to cross them out, it would be a hole. What about any other horizontal asymptotes? Remember, leading coefficient over leading coefficient, if the degrees of top and bottom are the same. So it looks like I've got a horizontal asymptote at y equals 1. Okay. And then if you plug in a few numbers, you will see that the graph is just a shifted 1 over x graph. All right, so now we answer the question. 2 from the left. Well, here's 2. Incoming from the left means like so. I'm thinking about all these points getting closer and closer to x equals 2. And I'm asking myself, what are those y values doing? They're getting smaller and smaller and smaller, going to negative infinity. And my last problem is this. Draw a possible graph with the following description. Okay, so I'm going to tell you that the graph has this. That means it has a point at 2, 5. Also, it's got a limit as x approaches 2, and it is 3. Now, I didn't say 2 from the right, 2 from the left, but I did say at 2 is 3. What conclusion can you make when I say that the limit of f of x as x approaches 2, like at 2, not left or right, is equal to 3? Hopefully, the conclusion is, conclude that limit from the right and the limit from the left are both equal and they're both 3. Okay, so let's sketch. First things first, plot that point. 2, 5. 2, 1, 2, 3, 4, 5. There it is. F of 2 equals 5. Check. Now I have to draw a graph that from the right and from the left meets up at y equals 3. So at 2, the y value of this graph has to meet up at 3. But guess what? It already has a y value of 5 when x is 2. How could that be? How could I have a different y value? That wouldn't be a function if I had 2. If this is a 3 and I put a dot here, then I can't, like, let's say I do this. Dot. That's not a function, you guys. It doesn't pass the vertical line test. I can't have 2 y's for the same x. But then at the same time, the limit has to be 3. Remember, I don't actually have to have a filled in dot. I don't have to have a filled in point. This could be an open circle. There it is. So open circle. Now it's a go. Is the limit incoming from the left 3? Sure is. Is the limit incoming from the right also 3? Sure is. Is there a function value at 2 that's equal to 5? Yup. Other possible drawings? Dot at 5? There. That's another one. There are so many possible ones. You could do this way. 1, 2, 3, 4, 5. Put a dot at 5. And go like this. These all work, so this is 3, let's say. Okay, so that concludes the limit notes. We'll do more examples in class, and thank you for listening.